Welcome to Tableau. My name is Daniel, and I will be presenting on the topic of understanding and optimizing queries. In this session, we will be exploring on the various queries that take place in the backend when Tableau communicates with the database and how we can improve the performance of these queries. In Tableau, it is our mission to help people see and understand data. And an important criteria to achieve that is speed. If a user can access the dashboard quickly and gets the results at the speed of thought, then he will be motivated to explore all the possibilities with his data, experiment with various visualizations, and create more enriching dashboards that appeal to the audience. Before we begin, let's take a look at the background of what happens when you open a dashboard. Two main processes take place. First is executing query, followed by computing view layout. Now, when you open a dashboard that is slightly slower, you might notice a window that comes up saying executing query and followed by computing view layout. Now, what happens during the first phase is Tableau queries the database to return the necessary records and generate the visualization. And in this phase, the less number of rows that's being returned, the faster it is. And if you have more complicated aggregations or joins that need to be performed in the database, then the database would need to do more heavy lifting work, and that would impact the performance. And then when you create calculations in Tableau, Tableau actually pushes these calculations to the database to crunch the numbers and return the results. So again, more complicated calculations will mean more work on the database. After the results are returned in the executing query phase, Tableau then computes the view layout. It will first sort the results based on, or actually it will first create or compute the various table calculations that is in the dashboard, for example, running total or moving average, and then sort the results before generating the marks. In a few tips and tricks that we will discuss on how to improve the performance, there are certain principles that we hope to achieve. And these are to reduce the number of rows returned. Now, if you're able to reduce this number of rows, then Tableau will work on a smaller sample, and that would improve the performance of the results being returned. Also, if you can reduce the number of queries to the database, that reduces the number of hops, round trips, lesser work being done on the database, and faster results. And if you have performant databases, especially columnar databases that's able to crunch numbers fast, you can leverage on that and push as many calculations as possible to the database and leverage on the computing power of that server. Also, it is important for you to understand the limitations of your database. For example, if you have MySQL database, and you would notice that MySQL database does not do joins as efficiently as compared with other databases like Oracle and MS SQL. Reason is the variety of indexes available in MySQL is not as many as compared to the rest. Now, in this situation, it might be better to look into blending, which takes the aggregated value from a database and joins it in Tableau itself. Another principle is to leverage on cache. If you can improve the cache hit ratio, store as much temporary results in the cache as possible, then the next user that comes in can have the better experience of opening and seeing the dashboard much faster. And cache is really something that's available in both the desktop and server as well. And for a lot of my customers who have performance issues, I would recommend them to look into Tableau Desktop first. And reason being, both Tableau Desktop and server are built on the same technology, same SQL technology, and so you will not get a better performance in server than desktop. Of course, you would want to also bring data as close as possible to Tableau, and you can achieve that in two ways. One way is to install Tableau in the same network as your database, so there's less latency in communicating with the database. The other option is to create an extract, in which case the data itself will be stored locally in Tableau server. Now let's look into the different tools that we can leverage on to solve the performance issues that we face. Firstly, you can leverage on the performance recorder that comes with Tableau server. Just go to Help, Settings and Performance, and run Performance Recorder. And after you do that, you would be able to see a dashboard of each query that's being sent by Tableau to the database and how long it takes to run them. Now we can copy and paste this SQL statement and run it directly in Tableau in the database to see how long it takes. Now from there you can investigate and troubleshoot the bottlenecks, whether it is part of the SQL statement or is it the way you create the visuals in Tableau. The other useful tool is the query optimizer that is available in most databases, in which case you can view the query execution plan and from there find out the different bottlenecks. Maybe a particular join is taking a longer time than usual, and you might want to improve on these join conditions on the way you perform the joins, for example. Now, where do we begin? The first place that we want to begin in troubleshooting performance issues is really to tune the visualizations in Tableau first. Now, this is where we look into the granularity of the data. Is it required for us to generate a view that shows all the details, or is it sufficient for us to just give an overview, an aggregated view of the data to the users? Also, is there a particular filter that you would want to use? Now, in Tableau, you would have different choice of filters. There are some filters that are itemized, some filters that are ranged, and we'll look into that in the demonstration later, how each type of these filters impact performance. Also calculations, how we can improve on the calculations and how certain fields are calculated faster in Tableau than other types of fields. A good resource for that is Alan Eldridge's book on improving workbook performance, and highly recommend you take a look and to see into more details how you can author more efficient calculations. Now, after tuning the visualizations, you can then move into tuning data connections. That is where you look into the initial phase of getting connected with the data and whether you use multiple tables or you need to use custom SQL. And if you use custom SQL, what are some of the best practices you can use so that it becomes more efficient? And also going all the way to the database, working with the DBA to tune the database, involving things like creating indexes on join conditions, enlarging the temporary space, so on. You can also increase cache hit by changing the cache settings in Tableau server, and also look into creating an extract if the underlying database is not performing. Now, the extract is a database engine, an in-memory database engine that is available in Tableau, and you can leverage on that capability to store highly compressed data for fast retrieval. So we'll start off first by looking into how we can tune the visualization, how we can improve on the filters, different types of filters, how we can make calculations simpler and more efficient, and how we can leverage on a method called guided analysis, which in a nutshell is instead of showing all the detail to the user, you use filters, drill-in capabilities in Tableau to allow the users to select a portion of data that he's interested in and then gets guided into another view and into another view until he sees the area that he's interested to analyze. So in this case, you avoid showing a whole bunch of data at the initial phase and that would improve the user experience and really improve on the speed of how the dashboard is being generated. There are different filters in Tableau, and some of these filters have precedence over the rest. The first filter are action filters, and they are very common filters which you can enable in dashboard simply by clicking or checking use filter on each view. And now, although that is a very convenient way, a caution on that is when you use or you choose to do it that way, Tableau by default would create an action filter on all the fields in the view. And sometimes that's not really very feasible in terms of performance. What you might want to do is to filter on the necessary fields. And we'll look into how we can do that in demonstration later. There are also range filters and itemized filters in Tableau. And itemized filters contains individual elements in the filters in which Tableau would send to the database. The database then would look into each items and compare it with the rows to see what matches in order to return the right results. Now, for the database to do that, it needs to look into individual items, and that takes time. Now, you might want to look into range filters, and that's a better way of sending the filter to the database, in which case the database doesn't need to look into individual items, but instead just look into a range. So it's just two values, the minimum, maximum, and find the values that's between. Much faster for the database to compute. There are also slicing filters, in which you have a filter condition which is upon a field not available in the view. Now, when you have such situations when the field that's being filtered on is not in the view, each time the user selects on a particular filter, Tableau would issue a query to the database to get the necessary results. Now, it can be expensive, and we can look into ways of how we can incorporate that field into the view and how that will actually greatly improve the performance when the user filters. Also, context filters is common for a lot of people who want to improve the performance, and essentially context filters is creating a temporary table in the database to store all the records that has been filtered, and then all subsequent queries is being issued upon that temporary table. Now, it is not a catch-all method for improving performance, and sometimes it can be detrimental to your performance. Case in point would be if you have very few elements that you want to exclude, and you use context filters. Each time you choose a different filter, Tableau will then recreate a temporary table, and that incurs a lot of overhead for the database. Finally, our data source filters. Data source filters are global filters for the workbook that shares the same data source, of course. And each time you create a new view that connects to that data source, that filter will automatically be placed in the query before it is issued to the database. Now, data source filters are oftentimes implemented as subquery in Tableau. And subqueries are not necessarily the best way of creating a query. The reason is, for most databases, they would create a temporary table to store the inner query of the subquery, or the innermost part of the subquery, and then from there create the final rows that's being selected. So in this case, it's really a lot of overhead, and some database actually treats subquery pretty well and optimizes this query, but not all the databases. So it's good. It's a good practice to avoid subqueries. Right now, we'll look into the demonstration, which I will show you the different filters as discussed. The first filter that we want to look into is the action filter. Now, notice if I click on any mark here, it takes a while for the next view to be filtered. Now, if we investigate further into the action filter, look into it, you will notice that all the fields are being filtered. And let's just choose a particular field instead in this case. Now, since every city belongs to a state, it should be sufficient for you to just filter on the state. Let's just do that and see how that improves the performance. And now if you click on each mark, noticeably the speed is faster. So it is good to get into the habit of going into the action filters and look into what sort of fields that you want to filter. Next, we'll look into range filters versus itemized filters. Now, it is very common for the user to see this view and say, maybe I want to exclude those candidates where the receipt amount falls below 0, and they can conveniently just exclude them. But notice what happens in the filter created. They are actually individual items, and some of them are excluded. Now, what happens is that this whole list will be sent to the database, and the database will look into each individual items and compare the right rows to be returned to Tableau. Now, it's pretty expensive since you have to go through each items. An alternative is really to not use itemized filters and use a range filter instead. So I can simply just filter on the receipt amount and the range of 0 to the maximum. Now you get the same view, but this is much faster. The database needs to now just look into a range and two values, the minimum and the maximum, and then just filter on any rows that falls in between. In the back end, you'll notice each time I click, a query has been sent. Now, as opposed to if I am to just include the state as part of the view, and let's just look into the query behind. Notice now no query has been generated, and see how fast it is. Now let's look into context filters. Notice if I am to just filter on each state, the response time is pretty okay. And let's just add this to context and see what happens. Now, Tableau issues the query to create the temporary table, index the column, and each time if I filter an element, it takes now a slightly longer time because now there's an overhead in terms of creating the temporary table and dropping the table, as you can see. Notice also there is a data source filter that is being added to the data source here. So if you look at the query that's being run in the back end, you will notice this condition year 2012 is being appended in the query that's being sent to the database. Now let's take a look into calculations. There are a few ways that we can simplify calculations, but it is important to understand how Tableau enumerates different types of fields in your data. In order of descending, the type that is evaluated the fastest would be Boolean, for example, true, false, followed by numbers, floats, integers, followed by dates, somewhere in between, and followed by string, which is the slowest. So if you look at the calculations following that, most of the users tend to write calculations like if sum of profit more than 0, then true, else, false. That could really be simplified as this simply sum of profit more than 0, in which case it could be true, or false and evaluated much faster than string. Also be careful of local computations that include table calculations, totals, subtotals, and performing data blending, in which the join is being done locally in Tableau. Now, table calculations tend to be more expensive in the local machine where you create or where you see the dashboards, especially if the table calculations involve a lot of partitions and for multiple dimensions. Just be careful of the sort of trade-off that you would incur when you have such analysis and between performance and the analysis they require. Also, avoid too many parameters. The reason is that when you use parameters, the values are dynamic. It depends on what the user chooses. And in that case, the values cannot be materialized or cached by Tableau. Now, remember one of the principles that we want to leverage on cache as much as possible. If you have parameters, then you can't leverage much on the cache. Also, during the initial phase of connecting to your data in the data exploration phase, there are a few ways or tips that we can use to improve that initial experience. Instead of just dragging the dimension into the window, you can use Describe, which is a very useful tool or an option in Tableau, in where you can see in more details the type of the fields you're connecting to and the available values for that field. You can also work with a sample of data by using top of filters, and you can actually go into custom SQL and maybe just select top 1000, or using extract and extract a filtered amount of data or a sampled amount of data, which we will show in the demonstration later, and that would greatly improve the performance initially, and you can again have that flexibility to do more exploration with your data. So we'll look into data exploration. So very quickly, instead of creating or dragging the entire field over to the table, what you can do is to right-click on the field and click Describe. It gives you a very useful information on a particular field. And in this case, the type of string, whether it's case insensitive, and if you click Load, you would just see some of the members that is contained within that dimension. Another way is really to use Extract. And notice there is a choice for you to choose top, maybe 1000 rows, or sample. Now, certain database, they don't evaluate top very well. Then in those cases, you might want to use sample and just sample on number of rows. So if you have too many views, it will take a while for all the views to be loaded. And I had this experience with a user who actually had, I think, about 100 worksheets in the workbook. Now that's pretty daunting. Each time when you open the workbook, it takes time to load all the worksheets. So it's advisable not to have too many worksheets in one workbook, but maybe create more than one workbook. Right? Also, some users, especially the novice, tend to create a dashboard that has filters on every field. So if you have 100 fields, that would be a lot of field to filter on. And each time the filter has been created, Tableau needs to query the database to populate the filter. So that's very expensive in terms of that generating the query. Also, network latency plays a part. If Tableau is very far away from the database, it takes longer distance for it to get the results, then that will impact the performance as well. Let's move into the data connection side of the story, and a few aspects that we'll be looking at: the initial experience of getting connected, how you can choose multiple tables, joins, and create views in the background in the database, and how to tune the database by creating indexes and constraints, how you can leverage on cache and also extracts to create a more compressed data, and also to reduce the size of the extracts. So the smaller the size, the faster it would be to access the data and create the dashboards. So we'll look into more details of when you're getting connected. Now, if you need to join multiple tables in one database, it is recommended that you use multiple tables. This is because if you choose the option of custom SQL, that entire custom SQL would be nested in each query that's being sent by Tableau to the database when you drag and drop to create a particular view. Now, that is, as I shared earlier, not very good for some databases. They don't treat nested queries very well. They tend to create temporary tables to store those results, and a lot of overhead incurred. Also, I have seen some users who, when they need to use custom SQL, added clauses like order by, which is unnecessary because order by can simply be done by clicking sort button in Tableau. So reduce unnecessary clauses. Also, if you have fields, in that case, the query optimizer would be able to leverage on the index and be able to perform the joins faster. Also, you can consider using blending, which is doing the join in Tableau itself by sending two separate queries to the database to aggregate the results first before joining it in Tableau. This method is especially useful if you want to show summary table, maybe just a couple of rows, and the summary table is actually obtaining the data from a huge table. Then in that case, it's really expensive to join a large table in the back end, but rather easier to just aggregate the results and into a few rows and then just combine them in Tableau. Now, there will be times when you will need to use custom SQL. For example, if you need to use certain functions in your database to get the results, or if you need to join on a specific part of field and such things, you will want to just use the custom SQL in which you can just paste whatever SQL statement that you want. Now, in this scenario, you can greatly improve the performance by adding where clauses or top, in a way that reduce the number of rows before you perform the joins. That would actually be much faster. And you can test the custom SQL first by running the actual query in the database. And if it takes longer, you can then use the query optimizer and try to troubleshoot which area is taking more time. Also, a great way is to create the views, which can be non-materialized or materialized, which is much better. And then Tableau would then access the view to get the results. Also, an important best practice is really to simplify any nested query into a join. Now, most nested query can be performed or can be rewritten into a join as well. So in most cases, the join will be performing much faster than comparing if it was to be in the nested SQL query form. Let's look into how we can tune the database. A few tips of tuning the database. One is to include constraints into your field when you're creating a table. Constraint like not now. You will be surprised at how much that will improve your performance. If you include a value as not now, then Tableau does not need to check for any null values in each field. Now that greatly reduces the overhead. Also, creation of indexes and statistics. Statistics is a way for Tableau for the database to understand more of the query pattern and then to improve on the query optimizer. You can create indexes, and it's best practice to create indexes on join conditions and where clauses, where the database needs to, like a phone book, look into the index and then from there into the individual values that's linked to it. Now, also don't over create indexes. Too many indexes then would also now it takes space to store the indexes. Too many indexes would waste space in the server, which can be used for other useful storage. Also, a best practice is not to use functions in the where clause. If you have an index that's been created in the where clause to improve the search or improve that joining process, when you use a function, for example, if the index is being built on the first and last name, and you use a function that just extracts the first name of a string, a substring function. Now the database then would not be able to leverage on the, let's say, a hash index that's been created, and because it needs to evaluate every single row using the function, that will not be leveraging on the index. So in this case, your index is useless. So a better way of doing it is to separate that field into first name and last name, and just to create an index from the last name, since you need to use that in your where clause. Another useful best practice is to create partitions in the database, especially for data that's being closely queried together. A good example would be dates. Maybe for your business application, you tend to query dates that are close, for example, January to June. Then you might want to store all the rows partitioned by dates, so that when Tableau queries the data, they're all very close to each other, and there's less overhead in the disk for it to jump to another segment to get the data. Other tips are like share resources. Now, in the database, there are a lot of areas of the database that's being shared by many applications. One of those resources are the temporary table, and it's often a point of contention among many applications. So it's a good practice, firstly, to grant the permissions to Tableau to create temporary tables. Now, if that is not granted, then Tableau will face difficulty or failure in creating a temporary table that's necessary to improve the performance, and also allow a large temporary space for all of these temporary results to be stored. And specifically for SQL Server, the area that stores the temporary tables, for example, when you're doing joins, that would be the 10 dB portion. It's a good practice to allocate ample space for 10 dB, install 10 dB on maybe a SSD of high-performing hard disk, a separate partition from the rest of the database, because that would be usually 10 dB is the most active part of SQL Server. Also, some databases support query banding, for example, Teradata. In Tableau, when you connect to Teradata, you can specify query banding. It is a way of banding each query that's being sent to the database, in which case the database can investigate each query and find the value or the field that you attach to each query and make necessary actions. Now, one of the benefit of that is to really allow the database to see if this query is sent by Tableau, and then assign a higher priority on that query. happens when multiple applications are accessing the same record or same table, in which case the database will lock a table that is being written by one application so that another application will not read any data that's not being committed yet. Now, if it is not important for you to read committed data, then in certain database in Tableau, we can specify read uncommitted. For example, in SQL Server, you can actually just check read uncommitted in the connection with SQL Server. Then in that case, then the database will not lock the table, and Tableau can just read the data and without contending with other applications. And that, of course, would in that case, then Tableau's queries will not be queued, but Tableau would be able to access the data right away. The other way is to create aggregated tables. And sometimes you might have a large table that contains many data, and the dashboard itself is only showing the aggregated amount. And in such cases, it is much better for you to just create an aggregated table, and that aggregation can be scheduled to be run maybe on a daily basis, and so that Tableau would then has a smaller table to access, and you would get the results faster. Next, let's look into cache. There are different levels of cache in Tableau Server. We have the query cache, in which is specific to a unique combination of database connection and username, and that's the query cache resides in each vSQL process. So each time then when Tableau queries the database, the results will be cached and saved in Tableau Server. So if another dashboard needs to issue the same query, then Tableau will not go back to the database, but instead use the cache results. It's important to note that this is specific to each vSQL process. So if you increase more vSQL process, then there will be a chance that the user that sees the same dashboard might not keep the cache in the which was stored in the product vSQL process. So it's really a balance when you have a lot of users accessing it and you want to increase the number of processes, but in that balance, there is a chance that the users might not keep the cache. There is the model cache, where it's dependent on the dashboard size. So it's a good practice when you create a dashboard to fix the size and not to use automatic, because Tableau would cache it based on the dashboard size. Also, when a dashboard is being rendered in the browser, certain number of data points is being brought along and saved in the browser, so that subsequently when the user interacts, if those values, those data are already stored in the browser, there is no need for a query back to Tableau Server to get results. Now there is a limit on that, and beyond a certain number of points, and Tableau decides that it is much faster to go and get the next set of results instead of storing too much data points in the browser. Now, extract is a great way if you have a slow database of really creating that compressed data in Tableau for faster access. When you create an extract, two factors come into play. Number one is the number of rows, and number two is the number of columns. Now, number of rows impact the query time, and the number of columns would impact the time needed for you to create an extract. So it's recommended that when you create an extract, if you do not need to see detailed data, to just create an aggregated extract, roll up the dimensions and dates, and also to remove duplicates in the process, so that the eventual size of that extract would be smaller. Also, a good way is to filter out unnecessary data that's not required by the business, and Also to hide unused fields. Remember I mentioned about the columns. So lesser columns will be a faster time to create the extract. So reduce the number of columns, and so that it takes a faster time to create the extract. Now we go into a demo section, and we'll look into how we can make use of what we have learned later and this apply into Tableau. In this first example, I will explore the behavior of join culling in Tableau. Now, notice if I go into the connection, this view is actually generated using a join between two tables. But in order to generate this view, candidate ID and receive amount, there's actually no need for Tableau to query to do an inner join with the second table. It can be done just by querying the first table, which is the table that contains the candidate ID. Now, in prior version, it will need to enforce that referential integrity in the database before Tableau can recognize that actually Tableau doesn't need to query the second table and just the third table, not needing to do that join. But in the latest version 8.1, there's an option for you to specify join culling behavior, or specify in Tableau terms to enforce referential integrity. Now let's go in and enforce referential integrity. The tables. Notice there is a checkbox here for you to assume referential integrity. Let's just click on that, and now let's drag field here. Now notice now the query that's being sent, there is no inner join. Tableau right now recognizes that these two tables are related using by primary and foreign key, and it's totally unnecessary to join the second table in order to get the results that's shown before you. Alternatively, you can use blending instead of joins. So this example is just connecting to a single table, not a join. And if you want to see the candidate name, you can simply just drag candidate name beside that. So this is using the example of not using joins if it is slow in the backend, and instead of using blending where the join is being done locally in Tableau. Alternatively, you can use aliases. So I'm going to show you an example here where you can just click on the candidate name, and one way is to key in the particular aliases. So I can just key in, for example, Thompson, Fred, Dalton. Okay, click OK, and you see that the name actually is being shown here. Now you can do that for the rest. If you don't have a lot of fields, you can explore this way of doing it, and it's much faster. And so subsequently, you only need to join to one table to get the results. Next, we'll look into an example of custom SQL. So there are times when it is inevitable for you not to use custom SQL, and that involves certain more complicated queries, and you just need to use the raw SQL statement. Now, this is one example which uses custom SQL. We can just go in and take a look at the query behind it. Fairly complicated query. What happens is that, and in order to generate that view the dashboard, this actually aggregates two different tables up to the month level before doing the inner join. It's something that you need to do in custom SQL, but notice the performance impact on that. Trying to filter a particular value, you see it takes a while to executing query, and before it computes the visualization, computing the view layout. So it takes about a couple of seconds here, and as the data amount grows, this will of course take more time. Now the second approach is really to look into blending instead of custom SQL. Now notice blending as well is a way of getting the aggregated value. Right? Instead of in the first case where we aggregate and then do the join, now we aggregate it from the database but do the join in Tableau by just matching the summary results returned. So you can see that the summary results returned are just about 8 values, so it's not a lot for Tableau to do the joins internally. So let's see how the performance changes. You can see the previous view was about more than 10 seconds, and now it's less than 10 seconds. It's not very much faster, but you can see improvements in that. Now let's just look into another way of doing this. And in this example, we are accessing a view. Now instead of using the raw SQL statement in the custom SQL, we are actually we have just created a view in the database and connecting to this view. So the view's name here is this compare contributions expenditure. Let's see how that impacts the performance. Now notice if I do drag, it's really much faster, almost instantaneous. Now next would be to look into further resources that we can access to find out more information on how we can improve query performance. So these slides will be shared, which contains the links, and you can access and read more about the information on the topic. Thank you.